Hello, friends. So let's start with problem number 82. Remove duplicates from sorted list 2. Here in this question, we are given with a list in which we'll have like a lot of elements which are repeated, right? The question says that you have to remove all such elements. So, for example, in this example 1, we have 3 and 4 repeated twice. We have to remove them all together, and the final result is 1, 2, 5, right? A very simple question, of course. So we'll discuss the approach, a single approach, of course, because it is sufficient. And but of course, before that, just look at the question, right? Sorry, look at the solution part. Here we are given with a function, right? And this function basically returns a list node, right? This list node is basically the pointer, the header, right? The pointer to the head node of the resultant list. For example, in the example 1, we have this resultant as 1 to 5, right? We have to return the head pointer, which will be pointing to 1 at the end. Okay, after processing the first list, you'll be getting a new list, and you have to return the head node of the second list. This is the question. What do we get in the input? So we get the whole list, we get the head of the first list. Okay, so this is function delete duplicates that we were discussing. Now let us discuss in detail the approach. So here we are suppose having this particular list, right? So see, we are going to maintain here two pointers. The one which will be called as current pointer. Okay, so the current pointer basically will denote the size, the list, basically the list up till where the condition has been checked. Okay, so the current basically is denoting the place up till where the list has been checked, and this is basically the current node which will be checked next. All right, and previous will denote the list until where everything is correct in order. The following rule is being followed here, right? So let's not move into this words and all. Let's directly start implementing it. So for example, initially previous will contain nothing, right? Because at the start, we don't have anything which is following this condition. We have not checked for it, right? So previous is pointing to a dummy node, right? And we'll point this dummy node connects to this one, right? We'll connect these two nodes. So initially the list which we have checked is just empty. There is nothing that we have checked, and current node will basically point here, because current means that which is the current node that you want to check, right? What do we want to check? Whether this particular node is same as the next node or not, right? So the condition that we are checking for would be this, that if current dot val is equals to current dot next val or not. So okay, so this is the condition that we are looking for. So we started comparing. So we checked for this, that if current dot val, which is 1, is it equals to current dot next. So current dot next is this node, so current dot next dot val is 2. So we are checking for this, that is 1 equals to 2, and of course the answer is no, it is not equal. If this is not equal, then we can infer from this particular case that, right, so we can say that the previous now will be this one, because this is until where we have checked for the for this particular condition, that there is no repetition, right? Or if there are repetitions, then we have removed it. We are considering this. All right, so this is the list, this is a previous list which we are considering to be right, and now current will point here. So now we'll make the current to point to the next node. Again we'll check for this condition, is 2 equals to 3, and again the answer is false. If it is false, then we'll just move the pointers, right? So now we will say that the previous will point here, right? Previous basically denotes the list up till where we have checked for this condition. If there are any kind of repetition, then we are seeing that we have removed them all already, right? So previous is pointing here, and current will go to the next node. Again we'll check if current dot val is equals to current dot next val or not. This time it is equal, right? If it is equal, then we'll be looping. Okay, we'll be looping over the elements which are sharing the same value. So here what we are going to do is we are going to just move this current pointer, right? So current will now move to this place. Now previous is not changing. You have to keep this in mind, because we want to do something here. We want to just remove these all elements which all are repeated. So we need to keep this previous to this, stick to this place. Okay, so we are just moving this current pointer, and again we are checking the if current dot next is equals to, this condition is again checked. So is current dot val is equals to current dot next dot val, again it is equal, and we just can move this current, right? Okay, so again we are checking for the same condition, that is current dot val equals to current dot next dot val, and this time the result is false, right? This time the result is false. It means now you can shift this previous. Then again the same condition has to be there, which is previous, the next of previous now again will point to current dot next, right? So this time what we are going to do is that previous dot next should be equals to current dot next. So current right now is here, previous is here, and we want to make a connection between the next of current and next of previous. So this connection has to be made, and after making this connection we'll lose this particular connection, right? And we'll move the pointer of current to this place. So now current is pointing to 4. Again we'll keep on checking for the same condition. So is current dot next is equals to current dot next dot next, again it is not equal. If the thing is that if it is not equal, then you can just shift current and previous by 1 places. So now previous will point here and current will point here. Again check for current and current next. These values are again equal, then move current by 1, and you cannot move previous at the moment. So again current and current next are equal, so just current will move. Again they are equal, and just current will move. This time they are not equal, then this shift has to happen, which is previous is here, so previous dot next should point to current dot next. So this link has been set up, and this will be removed, because of course there's only one link that can be formed, right? And if, again what we have to do is that we have to move current by 1 position, right? So now current is here and previous is still here. We'll check for the next element, but of course there is none. So if it is not there, then we can terminate the process. Now at the moment, if we say that the head was here, suppose, right? So previous is also initially here and head is also there. So the final list that we'll get would be head is still pointing here, and then head is pointing to 1. The link is intact. Then 1 is pointing to 2. The link is intact. From here the link was removed and a new link was formed to 4. So this link is there. Again from 4 to 6 the link was made. So 5 is also removed. And of course 6 is pointing to null. It will keep on pointing to null. So this is the final list that we are having. But we have to return the new head, which is 1. Of course this, if suppose 1 would have been repeated here multiple times, then that new link would have been here, right? So if we'll return this head dot next, this is basically the new head of our new list, right? If instead of 1 we would have here 3, 4, whatever the thing would have been, this link would be attached to that particular node, and we are returning that, right? We cannot return this dummy node. This was just for our previous case, that what is previous at the moment, it was just set for that, right? So we can now just return head dot next, which is basically this node, which is our new head. In our case this is our previous head also. It can change if the element that is repeated is starting from the very first position, like this. If the list would have been something like this, then maybe these 2 nodes would have been removed as well, so the new head would have been 2. So for such cases we'll keep head here, and whenever we'll point head dot next, it is basically the new head or the head which is of our new list, right? So how do we implement this particular problem? Let's start with that. So it is going to be a very simple approach at this moment. We know it now. So how's it going to be? Let's see. So first of all, we need to have a dummy node. So list node dummy node, we are creating a new node, right, is equals to new list node, and that's it, right? Now we need two more pointers that are next and previous, sorry, current and previous. So list node current is equals to dummy node, and of course we need this attachment also, that is we want our dummy node to point to the head node, right, the current head node. We want to make that connection as well, so we are doing it here. So dummy node dot next is equals to head, that connection, the first connection is built, and afterwards the current is now pointing to dummy node. Of course the current will point to head and previous will point to dummy node, right? So list node current is equals to head, right? And afterwards we can start with the conditions, that is, so we have to, of course, first of all we need to have this loop wherein we are checking that have we traversed the whole list or not, right? So for that we'll make this particular condition here, which is if current is not equals to null, then you'll keep on looping, otherwise this is the end. After the end you can return dummy node dot next. Okay, so this is what we're going to return, and inside this particular loop we're going to check that if current dot next exist, right? If it is there, if it is not equals to null, then we can check for this condition, that is current dot val is equals to current dot next dot val, right? So let me show you here, right? So we're checking for this condition. If it is equal, then okay, we'll see what we have to do. If it is not equal, then there was a simple case wherein we were just shifting the pointers, the previous and current pointers, that is we were just doing something like this, that previous should be equals to previous dot next and current is going to be equal to current dot next, a simple arrangement, rearrangement basically, wherein if they are equal, the value of current and current dot next dot val are equal, then we have to keep on traversing until we find the next element which is not equal, right? So here we'll have this loop while the same condition we are checking, and this time we are saying until this happens just move the current pointer. So current equals to current dot next until we find a new value. As soon as we find a new value, what we're going to do is that we are going to make a shift in the pointers. So now we'll say that previous dot next will be equals to current dot next, right? And now you can move the current pointer also, so current is equals to current dot next, right? So this link has been formed and current has been shifted to the next position, and that's it. So this is our whole logic. If we'll run this code for our first few cases, we will see the result. So the case 1 and case 2 both are passing. Let's submit it. So the case is successful, right? So this is how we're going to do it. Right, so it is a 0 millisecond solution which we need, of course. So this is the only solution which we're going to discuss for this particular case. There are many such solutions that can exist, but this is the most important one for this particular problem and should be known. So yes, in this question we're going to discuss just this one. So thank you guys. I hope that you'll like this video, and if you do so, please go and check out my different videos on LeetCode questions. Thank you.